This is problem 8-60. Without using a calculator, find the solution to each equation. Okay. So for the first one, we have an exponential problem. I'm write down here, 2 to the x equals 17. So what we needed to do was get this x out of the exponent. And so we can do properties of logs to do so. So we're going to use the power property, which means I can bring this x down in front of the 2 as long as I put a log in front of the 2 and a log in front of the 17. So I'm going to do this one step at a time here. So I just put a log in front of each of the numbers, and now I can bring down the x in front. I do that with this. So now I'm removing this x up here, and now it went down to the front. Okay, so that was the power property. So now we need to solve for x, so we're going to divide by log of 2 on each side. And this says to not use your calculator, so basically our answer is just log of 17 divided by a log of 2. And remember, these are numbers, so there's a value for x, but without using our calculator, we can't really come up with it. And that's fine, because it says not to use your calculator. Okay? So part B, we are given a log equation that we need to solve. Log base 3, that's a little 3, of x plus 1 equals 5. So going from logs, we need to get this x out of the parentheses, out of the logarithm. We don't want this here anymore. So we can do that by going around the world, which means, that's kind of a phrase that you may hear your teacher say, but we're going to do this base to this power is going to equal inside the parentheses. Okay? So we're going to remove the log now. So I have 3 to the 5th power as my exponent equals the stuff inside here, x plus 1. So now that's pretty easy. 3/5, you can either leave it like that, you can know it as 243, or in this case, what they don't want you to do is type this into your calculator. If you need to evaluate what is 3 to the 5th, that's okay to do. And then so we're just going to subtract 1, so we get 242 is what x is. That would make that equation equal 5. Okay? So now on to part C and D, which these look a little bit more different. I'm going to move my board up here. These look a little different, and we have logs and exponents in both of these problems. So I'm going to show you, C isn't too bad, but D I'm going to show you kind of with substitution, and it'll make a little more sense. So let me write down C here. Okay, so we have another log problem. So just like we did up here, we're going to do around the world. So 3 to the 4th is going to equal the stuff inside here. Okay, so 3 to the 4th equals 3 to the x. So it's pretty obvious now, what does that exponent have to be, this x right here, to make these equal? Well, these 3's are already equal, so this x must be 4. Okay, so that's why when we see problems that look like this, they have this base and this same exponent base, that they kind of maybe think about them canceling out, but this is really why that's happening. Okay, and so for D, we have an exponent problem. 4 to the log base 4 of x equals 7. Okay, so here I'm going to do first, let me write it in a different color. I'm going to write a more simple problem down. So this is, but it's still in the same format. So I'm going to say a to the x equals b, which is the same exponential format here. So in our little black original problem, a would be 4, x would be this whole big log base 4 of x thing, and b is worth 7. Okay. Now to change that, just like up in part A, we had to make a logarithm, or we had to add logs to both sides. So I'm going to change this red problem into a log problem, okay? And that's to get this x out of here. So I'm just showing you with a simpler one. So this would become log base a, and then regular b, let me put that in parentheses, equals x. So remember, if I were going this way, go around the world, a to the x equals b, that's what we started with, okay? So I'm just showing you how that relates with a simpler problem, and now we're going to fill in kind of with substitution what goes where. So a was worth 4, so in this problem this should be a 4, so it's log 4. Our b was worth 7, so I'm going to put this here, and x was this whole big thing. So that's going to go over here. And I'll put these in parentheses so you know which one's the base and which one is the number. So now, again, like C, it's kind of obvious. This is log base 4, log base 4. This 7, this must be a 7 also. So that's why we know x is 7. So again, same thing when we had an exponential base and then the logarithm base are the same numbers. And then it kind of seems like it cancels out, but here's really why. So we substituted, I made this a simpler problem. This is the same setup as this original, this ax equals a to the x equals b, but just much simpler. We changed that to a log problem to get the x out of the exponent, and then I just substituted the original letters and numbers back in where they go. All right, so that's how you solve logs and exponentials without a calculator.